Well, here we are, the next to last video. We're going to find the cosine series in this video. I gave that as a sort of assignment in class. Now, if this is f of x, in other words, if f of x is a power series of this form, then ak is equal to this. That's our formula. We did show that in the last video. So we want to find the series for the cosine. That means we need to find this formula here. And so that's what we're going to do here. And I'll start things out for you. And so we need to take derivatives to establish the pattern. The 0th derivative is the same as the function. The first is therefore minus sine. The second is minus cos. The third is going to be the derivative of minus cos, which is sine. The fourth is cosine. And notice we're right back where we started. And because of this, the derivative cycle. I take the fifth derivative of this, that's the same as this, which is the same as the first derivative. The sixth is the same as the second. The seventh is the same as the third. And I take the eighth and I'm right back up here. And this pattern will continue. So I'm just going to indicate that here. So, well, I need to figure out what the kth derivative at 0 is. So again, we'll try to establish the pattern. So if I take the 0th derivative, plug in 0, well, that's going to be cos of 0. And that's going to be equal to 1. Now remember, so that means this whole line here is going to be 1. I do the same thing here. The first derivative at 0 is going to be the minus sine of 0, which is 0. And that's going to be the same as the fifth, the seventh, and so forth. So we get that one. Okay. Well, the second derivative at 0, well, that's just going to be the opposite of this. Minus cosine, that's going to be minus 1. And that's going to be the same for the sixth derivative, the 10th, and so forth. Don't need to indicate that. And finally, the third derivative is going to be 0. Well, and that third derivative is going to be sine of 0, which is 0. And that's going to be the same for the 7th and 11th. So we show this, that the 0th derivative, we have our pattern. This is going to be 0 whenever k is even, whenever k is odd, at 1, 3, 5, 7, 9, 11. So that's when k is odd. It's going to be equal to 1 when k is equal to 0. We saw that here. Same at 4, same at 8. So we have that pattern. And it's going to be equal to minus 1 when k is even. So k is equal to 2, we get minus 1, 6, 10, and so forth. So that gives us a formula. So now we can use that and we can figure out what ak is. Ak, which is equal to the 0th derivative at k factorial, is going to be equal to just simply 0 when k is odd. It's going to be equal to 1 over k factorial when k is equal to 0, 4, 8. And it's going to be to minus 1 over k factorial when k is 2, 6, 10, and so forth. Okay, so that's our formula. So let's go and use it to figure out the series for the sine. So I'm going to move that up a little bit. So here's what we know. We know that for cosine of x, which is we're going to write this way, we'll figure out the pattern. We know that ak is equal to 0 when k is odd, 1 when k is 0, 4, 8. Sorry, it's 1 over k factorial, and then minus 1 over k factorial when k is a multiple, 2, 6, 8, and so forth. Okay, well that's going to be pretty easy. So using this, a0, well, that's going to be equal to 1 over k factorial, which is 1 over 0 factorial. A1 is 0. A2 is going to be equal to this, minus 1 over k factorial, minus 1 over 2 factorial, x squared. A3, well, 0. A4 is going to be A4 4 is going to be 1 over k factorial, so we're going to get this. Sorry, it should be a plus there. And you can probably guess the rest of these. Minus 0, and then minus 1 over 6 factorial, x to the 6th. So to clean that up a little bit, we're going to get 1 over 0 factorial minus x squared over 2 factorial plus x to the 4 over 4 factorial, and so forth. And this pattern continues. Okay, now we want to write this as a series. So that's the last thing I'm going to do. So move this up a little bit, get it straightened so it looks good. So this is going to be equal to a series. I'm going to start my count at 0 because that's standard. That's 0. This is 1. This is k is equal to 2. K is equal to 3. And you get a really nice pattern. You can see it. Well, this is going to be minus 1 to the k. This makes it positive uneven. Positive, positive, positive. My exponent is twice the index. So 2k over 2k factorial. Now, you might wonder this question. So we're saying this is equal to the cosine. So the question is, for what x does this work? And I'm going to address that question, and that's going to be the last one. Not the last video, but the last question for this. So cosine x, I'm just rewriting, has this formula, and where does it convert? Where does it converge? We're going to see that it converges for all x. Again, I'm not going to ask this on the test because I didn't really ask it in class, so it's not really fair for me to ask that of you. So I'm going to test this, and I'm going to use the ratio test. And it's going to be, this is my absolute AK. So it's going to be equal to absolute AK plus 1 over absolute AK. Okay, well, that's going to be x to the absolute x to the 2k plus 2. So remember, x to the 2k plus 1 is x to the 2k plus 2. And I'm going to get the same in the bottom, 2k plus 2 factorial, I have to fix something, over x to the 2k over 2k factorial. I forgot my limit. I'm doing a ratio. Okay, so I'm going to have to start over here. Let's see, we got this here. Invert and multiply, apply the absolute values. X could be negative, so that's the only thing I need to worry about. Invert and multiply. Okay. Well, that's going to be equal to the limit. Sorry, let's see the whole thing. Didn't mean to screw it up. K goes to infinity. X to the 2k plus 2 over absolute x to the 2k times 2k factorial. Now remember that 2k plus 2 factorial is equal to 2k factorial plus 2 more. Okay. Forgot the 2 there. Okay. Well, okay. So I'm going to get absolute x as k goes to infinity. In the bottom, I'm going to get, if I multiply this out, I get 4k squared. 2k plus 4k is 6k plus 2. But what's that limit? I'm sorry, this should be squared. this is going to be equal to some constant over infinity, and that's just going to be 0. So what this means is that this converges absolutely for all x. So this formula is valid everywhere. Any x you can think of, this will work. Now that's going to be true for the sine and e to the x. We saw that for the log and tangent it was limited to, I think it was -1 open to 1. But here, this converges everywhere. So it's on all real numbers. It's a great formula. So again, you might be wondering why I'm treating x as a constant. Once we plug in an x into this formula, what's changing is the k. That's what that tells you. So when I take this limit, I'm thinking that x is just a number. I don't know what it is. And I'm taking the limit as k goes to infinity. So it means x isn't changing at all. So that's why I'm treating x as a constant. And look over here, whatever number we get here, we're going to get something infinite in the bottom that's going to go to 0. Okay, hope that makes sense. Thanks.